Good morning. In this video, we are going to derive the equation for Miller capacitance. In the left side, we can see the common emitter amplifier circuit. The right side, you can see the small signal model. So from here, we start from R pi, C pi, C mu, G M, V pi. So this is the everything within these two dotted lines are the high frequency equivalent model for this transistor. So this is base and this is emitter and this is collector. So this is the base side. Take this point as base side, this point as collector side, and this point as emitter side. So whatever within these two dotted line is the high frequency equivalent model. We have already derived, how to draw the high frequency equivalent model, including this capacitors and resistance and this dependent source. Now to this, we are going to connect these components, biasing components. For example, we'll start with R1 and R2. So to draw the high frequency model, you know that all the DC sources, we have to nullify all the DC sources, which means we have to make this VCC is a DC supply that we have to nullify, which means that has to be grounded. So what happens here? To the base point, we have a resistor R1 and R2. R2 is already grounded. We have R1 which is also grounded. So from the base, we have this resistors R1 which is grounded and there is a R2 that is also grounded. Which means if you look from here, there are two resistors R1 and R2 which are in parallel. And again what happened? This coupling capacitor CC1, CC2 and this bypass capacitor CE, all the capacitors will get short circuit at this high frequency. So this from the base point there is another resistors RS that is grounded. So R1, R2 and R1, R2 and RS, three resistors will come in parallel in this high frequency model. This is the input, IS is the AC input current. So that will exist here. So this is the input AC current and R1, R2, RS are in parallel. And in the output side, you can see from the collector there is a resistance RC that should be connected to ground. We can see RC here that is connected to ground. And also since this CC2 is short circuited, from this collector RL is connected to ground. You can see from the collector point RL is connected to ground. What happened to the CE? CE is a short. So you cannot see RE you can remove RE because there is a short circuit across the capacitors. So this resistor is of no use. You can remove the capacitors. So the emitter node is directly grounded. So this is the circuit. From the circuit we are going to derive the Miller capacitance. So if you see here, you can see the dotted line here, there is a capacitance. To the left side of this capacitor, all the components are in parallel. There exists only one node here, this base node B. So all these are, so there exists a single input node and here also there exists an output node. So if you see C mu here, this is C mu. There is a one node here and there is another node here. What is the voltage at the left side of the node? So all the components are in parallel. You know that voltage across this R pi is d pi. So the potential at all this node is d pi because all the components are parallel. So I can say to the C, I'm taking only the capacitance C mu, just the dotted lines. Okay, the voltage at this node is V pi. What is the voltage at this node? The voltage at this node is V naught because here also all the components are in parallel. So the voltage at the output node is V naught. I have taken only the capacitance C mu which is connecting the input node and the output node. So input node the potential is V pi, output node the potential is V naught. Okay. Now what I'm going to do is I'm going to replace the capacitance C mu. So for that, this is grounded Let me take, this is the capacitance CP, whatever I have drawn within the dotted line. This is current, let me take the current I1 and this is the current I2, input current and the output current. Now I will write a KVL loop, KVL here. So this is the voltage here is V pi, the voltage here is V naught. I will write a loop equation first starting from this direction, minus V pi. So minus V pi plus what is the potential across the C mu, which is I1 multiplied by 1 divided by j omega C mu minus V pi. So minus V pi plus I multiplied by 1 by j omega C mu, and finally here it is plus V naught. Plus V naught equal to 0. Plus V naught equal to 0. This is one equation. From this equation I can get what is V pi. So V pi equal to I1 multiplied by 1 by j omega C mu plus V naught. Similarly, I will write a equation in terms of I2. So I will delete this. Now I will write a loop equation in terms of I2. Minus V naught, so in this side, in the anti-clockwise, minus V naught plus I2 multiplied by 1 divided by j omega C mu plus V pi equal to 0. So from this equation, what is V pi? Sorry, V naught. V naught equal to I2, sorry, V naught equal to I2 multiplied by sorry, 1 by j omega C mu plus V pi. So we got these two equations. Kindly be note, we have started from this circuit. Just I have drawn only this C mu. From this C mu, we have derived these two equations. Again, I am going to represent these two equations in a form of circuit. So if you see that taken the first equation, V pi equal to, there are two terms. I am going to just draw this equation. How to draw? The total voltage is V pi. The total voltage V pi, that is the total voltage is V pi. That V pi is going to be equal to the sum of two components. One is the potential across the capacitor, another one is V naught. So this is C mu and this is V naught. This is plus and this is minus. I have just drawn this equation. So for example, if I want to draw Vt equal to V1 plus V2, so this is the total voltage Vt. That is equal to V1. This voltage is V1 and this voltage is V2. Okay, the total voltage equal to sum of the voltage across these two components which are in series. Similarly, here the total voltage is V pi, that is equal to the voltage across the capacitive component, and there is a voltage V naught. So V pi, the first equation I have drawn. Similarly, I want to draw the second equation. Second equation, the total voltage is V naught, which is the output voltage. So this is V naught. The total voltage is equal to the voltage across the capacitance C mu plus there is another voltage V pi. Okay, so you have to note that I have drawn V naught and V pi as a dependent source because V naught is actually the output voltage. So V pi is the input voltage which is here. So in this place I have drawn that as a dependent source. So this is for the first equation and this is for the second equation. Now what we are going to do is we are going to replace this C mu, a single capacitance. We are going to replace this C mu by this complete circuit. So I'm going to redraw that. Now we can see here I have drawn the complete circuit. IS, RB, V pi, R pi and C pi. Here GM, V pi, RC and RL. So between these you have to replace this C mu with this circuit. One more thing here. So this is C mu and this is V naught. If you see here, this V pi and this j omega C mu, this impedance are in series. So I'm going to replace it by a voltage source. You know that a voltage source and a resistance or impedance in series can be represented by a current source and a impedance in parallel. So by using that, I'm going to represent this as a current source and this capacitance j omega C mu and this in parallel. So this voltage source and impedance in series is replaced by a current source and a impedance in parallel. So this current source can be represented as I equal to, which is V pi divided by 1 divided by j omega C mu. So now this entire part of the, instead of this C mu, I am going to replace this entire part. So from here, there is a C mu and here it is V naught. That is in the input side. In the output side, there is a capacitance. The capacitance is j omega C mu and after that there is a current source and these two are connected. So this value of this current source is V pi j omega C mu. Okay, so from this we can compare. There are two current source. One is this V pi j omega C mu. Another one is GM V pi. So this GM, the value of GM is very larger when compared to this j omega C mu. Okay, by applying this, you can redraw the entire circuit as, so there is a IS, RB, R pi, C pi, and here it is C mu, V naught. It is input side. In the output side, based on this approximation, I am going to neglect this current source because this current source is of can be neglected compared to this current source. Similarly, this impedance values, this j omega C mu, this value is Now I'm going to replace this C mu and this B naught. I'm going to replace this capacitance and voltage source by a single capacitance Cm, which is the Miller capacitance. So the value of Miller capacitance is C mu multiplied by 1 plus Gm Rc parallel RL.